What's up guys, Fernando here. Welcome to a new video about catalyst converters. In my video before that, I processed some catalyst converter and I show you how to easily get noble metal from a converter with just in a couple of simple steps, okay? And for me, it's a easy way. And most simple way to do that, okay? But if you remember, I saved one piece of that converter just to show you a second way how you can recover if you don't have nitric acid. How you can recover noble metal from that catalyst. Unfortunately, this converter which I have contain only platinum, not any other, not palladium or rhodium. For me, it's never mind because I don't care what I'm going to sell, platinum, palladium or rhodium. Expected for rhodium here in Serbia, I don't have any buyer, okay? Even palladium is hard to sell, but platinum is very easy to sell in a full price, okay? And if you remember, I saved a little piece, one piece of that converter. And in this video, I will show you how you can get noble metal from that converter without nitric acid. You already see that in some of videos on the YouTube. I will use hydrochloric acid and bleach, and this is a slow step. You just basically drop that catalyst pieces in the dish, add hydrochloric acid, and every single day add little by little bleach, and in that way you can make the chlorine gas, which is dissolved metal, stay in the solution. This piece of converter I hold in that jar, which you see in the video, about three weeks, and it took too long. The reason why I do that, why I'm not process all the converter in the last video, it's that I want to show you that this is not best way to recover noble metal from catalyst. Why? Because I think my personal opinion is that bleach is not strong enough to recover platinum. Palladium will easily dissolve by bleach. Rhodium, maybe, I don't know. But platinum is very hard to dissolve. I mean, if you had some bead of platinum, you need to make your solution hot on 60 and some degrees Celsius just to start to dissolve, dissolve that platinum bead. So that converter is plated on one side, ceramic, on one side with metal. And that bleach attack only that side, but it's not have contact with the other side because of substrate, of course. And I think that it's very hard to dissolve all the platinum metal. So this video is just used for a purpose that I want to show you that bleach cannot dissolve all the platinum from substrate. Of course, I leave that substrate whole because if I crush that substrate and I add it in beaker, I need to stir that on every couple of hours, and it's much better when you leave just bigger pieces for acid and bleach, so acid can go through the substrate channel, okay? So let's start with the video, but before that, this video is sponsored by Process Machina, and now in this picture I will show you all the steps how they produce machines for every single step in the process for noble metal recovery from a catalyst converter, and of course machine which is make all that waste safe for disposing. Okay guys, so let's see that. Okay guys, this is one different part of this video. I just leave just one part of the catalyst. I want to show you a third way. You already see that way on the Cody's Lab 3 tips and the other channel. This is how you can recover palladium, platinum and rhodium with the bleach. So it's much easier to just leave the substrate in bigger pieces for this, to stir that, and when substrate look like this you need to stir that all the time, but in this you just add little by little bleach and recover all that step by step. So right now I will just fill this little jar with this piece of substrate, only with the bigger piece. Okay. Now here I'm gonna add some hydrochloric acid and I'm gonna add little by little bleach for the next 15 days. Okay. Okay guys, so I filled that over the catalyst pieces with the hydrochloric acid. Now I have bleach, and right now I will add just a little bleach, and every day, maybe a two time day, I will add just a little by little bleach for the next 2 weeks. Okay, be careful, this produces chlorine gas. So you just fill that, but not too much. We just want the chlorine gas stay in solution, because the stuff which dissolve the noble metal is actually chlorine gas in solution. Okay, so we're gonna leave that until tomorrow, and tomorrow I will add more bleach, and day after day I will add more and more bleach in the next 2 weeks. Okay. Okay guys, so after almost I think a 3 week, so about 20 days, I add every day in this jar little by little bleach, and of course I stir and cover the jar so everything stay inside, chlorine gas. Solution is yellow, pretty yellow. I expect, because this catalyst converter contains platinum, I expect that will be much red, but not that yellow. But I think that reason for that is actually because there is still platinum in the substrate. I think that the bleach not success to dissolve all the platinum from substrate. Okay, because I still think that Aqua Regia is the best stuff, and when you got solid platinum button, you need heat solution over the 60 Celsius degrees to dissolve that bead. So I think that even this platinum on the substrate is not that much thick. I think that still need some source of heat to dissolve all that platinum. Okay, so never mind. About 20 days, 21 day, I think this substrate stay in this solution. So right now I think that is enough. 1 week more will not make big difference. I will decant that, and I will add this solution on a slowly heat. I want to evaporate all bleach from it, so I can stay only with the hydrochloric acid and metal inside. Okay. Okay guys, it's finished. So right now I want to show you something. So this is our bleach, hydrochloric acid and bleach solution. First solution, which I treat that substrate. This is first solution, acid and bleach. 3 weeks in acid and bleach. From 800 milliliter I evaporate at 500 milliliter to remove bleach. See that? My gloves is very dirty, sorry. Solution is has very nice color and contain platinum. You already see that on a stainless test. But after I wash a couple of times the substrate and I put that on the heat with the aqua regia to check if there any more platinum inside, and see that solution is very red, practically the same like this one. See that? Very strong color. So this solution contains platinum too. So what my point is that acid and bleach, no matter how long time, cannot remove all the platinum from the substrate. So this is possible way, but this is not the good and the best way. The best way is actually aqua regia. So you see that this is acid and bleach, and this is aqua regia after this substrate is leached by acid and bleach. See that? The both solution contain platinum. So acid and bleach could remove platinum, but not all amount from the substrate. This is not a good way to leach platinum metal from the substrate. Okay guys, so right now what I'm gonna do, I think that I remove all the chlorine gas from it by evaporation. So right now I'll leave that to cool down. These I will process the same like the last time. I will
decant that, and I will now, when it's still hot, I will add urea, dinox nitric acid, and I drop that platinum with aluminum, okay? Okay guys, so after a couple of hours I got this to solution. In this beaker is a solution from bleach, hydrochloric acid and bleach, and in this beaker is a solution after I once again treat this substrate with nitric acid, okay? And this is our substrate. See that? Now it's clean. No more metal in it. If you see, this solution is still not settled down. Particles is a more complex. It's tiny particles, but this one, it's already settled down. And here on the bottom you can see nice, very nice, see that? Very nice platinum powder.
Okay guys, so now we are on the end of this video, and once again you see in this video that bleach cannot dissolve all the metal. I mean, a free week I leave that substrate a free week in the jar. Every single day I add some amount of bleach, so you see that amount of acid rise for this 20 days to this amount in the jar. And after that I filter that solution and put them on a heat to a vapor or all the extra bleach, and of course once again I drop that platinum with the aluminum. And but that substrate I process again. I process again with aqua regia, and you see that solution on test show that contain platinum, and you see by the color that color is practically the same like the first solution. So probably half of that metal stay after first step with the acid and bleach. So once again, this is not the best solution for converter catalyst processing, but if you don't have access to nitric acid or the other strong oxidizer, the bleach can help you that you recover some metal from a converter catalyst, but probably you will lose some metal in that process. Okay guys, now once again we will see the picture from the process machina, every single step, how they produce machines for machine and equipments for catalyst converter recycling and platinum metal recovery. Go on the side process machina and you will see that firm makes not just for a converter catalyst, they makes very good quality machines and equipment for electronic recycling and recovery of the precious metal. Okay guys. thank you for being with me in this video. I have one video about catalyst converter, and in the next video I will process that isolation from the box from converter. They contain some isolation like asbestos, I don't know, but they have some silver color flakes. It's not silver, it's not, I already tested that, it's not aluminum, but I think that is some precious metal, I don't know. So in the next video I will process that just for a test to see what is actually this stuff is. Once again, thank you for all your support, and for that you stay with me on my channel. Don't forget to subscribe to my channel, don't forget to hit that like button and share my videos, and of course the bell button for notification. Of course you can follow me on a BitTube, on the LBRY browser, and on the LBRY platform. And if you are in the crypto world, you can donate me some support in the cryptocurrency for Bitcoin, Ethereum, and LBRY coin, and the address is down there in the description. So I will see you in the next video. Cheers.